Welcome to my new calculus channel. My name is John Gabriel. And if you recall, in a previous video, I showed you how to teach your preschooler or your little toddler about the number of concept. This particular video here, let me show you. This video here which says teaching your preschooler about numbers. And it's a 7-minute video in which I also gave you a PDF so that you could review the details, teach yourself first, and then show your little preschooler what it means to be a number and deriving all the rational numbers from nothing. Okay, so now in this particular video I want to show you how you can teach your preschooler the arithmetic mean, which is the most important concept the second most important concept in mathematics. The first one obviously being the arithmetic mean. Okay, so now why is the arithmetic mean so important? Well, because without it you can't calculate area, volume, and you simply cannot even do the things that you do in calculus. In other words, the integral, the derivative, all those things are actually statable in terms of the arithmetic mean. So it's a vitally important concept. How should you introduce this concept to your toddler? Well, you could begin by not even using the expression arithmetic mean, simply telling your toddler that if you have certain piles like that, certain piles of blocks or discs or whatever you want to call them, and you tell your toddler, well, how are we gonna make all those blocks, all these piles equal? Okay, and well, you could say, well, if we remove this block here and put it on top of this one, right? And actually, let's have another little block there too. So let's say we have 5 piles. So if we remove this block here and put it on top of this one, and then we remove this one and put it on top of this one, then all the piles will be equal, right? They'll all be equal. They'll all have 2 blocks, as you see here. So really, the arithmetic mean is just that number which would represent all the height of these blocks if they were made equal through redistribution. So what you do is you teach your little preschooler that he can redistribute blocks so that all the piles can be made equal. And initially, what you want to do is you want to start off with blocks that will, work out evenly. So, for example, make sure that you can actually get a level with using unit blocks. So you don't want to, for example, have a situation in which you have something like this, and then you have an extra block here which you have to chop into 3 parts, because unless you've taught your preschooler about fractions, then you want to stay off that till he or she is able to grasp the concept of arithmetic mean. Okay, now an arithmetic mean, as I said, is very important in calculating areas. So for example, an area like that is really just the product of the arithmetic mean of these lines and these lines. Okay, in other words, this line here, line length multiplied by that line length. And of course, when you have in calculus a curve like that, that's precisely what you're doing, is you're taking this as one of the arithmetic means and you're finding the middle line, not the middle line, the arithmetic mean of all these line lengths, the vertical ones. And then you're taking the product of that and multiplying it by this line length here. And so you have a product of 2 arithmetic means giving you the area. And by the way, that's exactly what the Riemann integral is. Okay, but it's not defined properly. It's a very bad definition In other words, it's ill-formed because infinity is a chunk concept. But I don't want to waste too much time on that. Let's go back to your preschooler. So really the idea is to teach your preschooler that if redistribution doesn't make sense, then the arithmetic mean is nonsense. Okay. So for example, if you had 10 students in a class and 7 of them got 30% and 7 of them, okay, and then one of them got 90 and the other two 100, then the arithmetic mean is 50. And most educators would infer that this means all the students passed, which is absolute nonsense, okay? Now, can you see why calculating a class average is absolute rot? Of course, they cannot share their marks, okay, because that's what you're doing. If you have a pile of 90 and a pile of 100 and you have piles of 30 here, and then you redistribute all of them, you'll get 50 on each pile. That's what an arithmetic mean is. So it's completely meaningless to calculate an arithmetic mean in the case of class averages, but yet all your moron math teachers and professors do it. Okay, now what is another example of a meaningless arithmetic mean? There are many, but let me give you one of the most hilarious ones. Well, suppose you have this little guy here and this guy here and this guy here, right? They're all different heights. What sense does it make to calculate the arithmetic mean of these individuals? Because you cannot chop this guy's head off and put it on top of this one and then maybe rearrange parts of this guy's torso so that they can all be equal. That's preposterous. It's total bullshit, okay? Just like most of the stuff you learn in your math classes at school and university. So this is what you need to teach your preschooler, that an arithmetic mean only makes sense when redistribution makes sense. So I hope you knuckleheads have learned something from this and that you will teach your preschoolers correctly. And trust me, it will come in very handy because this is exactly what happens in calculus. And you may ask, well, how is it possible to find the arithmetic mean of all these vertical line lengths? It's possible because of the mean value theorem. And of course, if you watch other videos I produce, you'll see how I prove that the arithmetic mean is possible, even though there are innumerably many line lengths in this interval. And same thing follows with volumes, hypervolumes, etc. Well, I hope you've learned some lessons here and how you can train your little math genius to understand the arithmetic mean and use it not only in calculus and all mathematics, but also in statistics, and to be able to produce the correct inferences, to dismiss garbage like class averages or class arithmetic means, and all sorts of nonsense that you find in mainstream academia and pedagogy. Well, this is the New Calculus channel. My name is John Gabriel. Until next time, goodbye.